I'm Jamie Pryde. I'm from IBM in the UK. I'm a software developer. I've recently been working on FastEC and currently looking at pool migration. And while doing my software development, I've caused a lot of OSDs to crash and had to try and work out why they've crashed. And I've taken a look at some bugs as well and had to try and work out what's going on there. So I thought I'd put together a short talk gathering some of those things I've learned and trying to put together an introduction on how to debug a crashed OSD. So why do OSDs go down? Every OSD in the Ceph cluster has a status. It can be up or down. If it's up, it's in service. That means it's available to the cluster. It can do reads and writes. If it's down, that OSD is unavailable, or there are communication issues between the OSD and other processes in the Ceph cluster, and the OSD's been marked down. So why might that happen? There could be a hardware failure, so the drive that the OSD is using may have failed. The actual server that the OSD process is running on might have crashed for some reason. There could be network errors, so maybe there's an issue with a switch or something like that. Someone's pulled a cable out accidentally. There may be misconfiguration, so if you have invalid values in your Ceph config file, that could cause an OSD to go down. Or it may be that the OSD process itself has crashed. And that's going to be the focus of this talk. So if an OSD does crash, before you start spending hours diving into the OSD logs and really getting stuck in, there's a couple of places to check first. Ceph's cluster log, which contains error messages, warning messages, and informational messages. I've put a default location of the cluster log there. You might also be able to see it by running ceph-w to watch what's happening on the Ceph cluster. Or you could run the ceph health command. This might save you a lot of time and just immediately give you a clue or tell you why the OSD has crashed. So always worth checking these before going any deeper. If I have checked those and I still don't know why the OSD has crashed, this is sort of my typical process I use when I'm debugging why the OSD has crashed. So first of all, I've received an alert. If you're running a production cluster, you probably have some sort of notification service set up. If you're just doing development, you might be manually running the ceph health command, like I do, or running the ceph OSD tree command to see the status of all of the OSDs in the cluster. When I see one's down, I take a look at the OSD log for the OSD that's crashed. I try and identify the point of failure in the log. So where is the point where the OSD has actually gone down? Now, when I find that, I may see a message, an assert, or some sort of clue as to what's happened immediately, and I can check. That might point me towards something in the environment that's caused the OSD to crash, so a hardware issue, a disk running out of space, that sort of thing. After ruling those out, I follow that thread in the log backwards, going from the point of the crash, trying to go back to the root cause that actually started the process that caused the crash. And if I find that, maybe I fix that issue, maybe I raise a new issue in Ceph's tracker, or maybe I find an existing issue that someone else has hit and I add some notes to it, or document the actions I took to restore my OSD, or note what my resolution was. So let's go into each bit of that. So when you look at the OSD log, you're going to see lots and lots and lots of messages in it. It can be quite hard to read, but each line in the log has a certain format that looks like this, and I've taken one of the lines from my log and broken it out. The first thing we see there is the timestamp. It's quite self-explanatory what that is. It's the time when the message was written, but this is useful if you're collecting messages from lots of different logs, so different OSD logs or monitor logs or manager logs, and you want to build up a timeline of what's happened. Next, we have the thread ID. I'll explain why this is useful in a second. And we have the priority of the message that's being printed. So the lower this value is, the more critical the message is. So something with a priority of 1 is pretty important. Something's gone wrong. If something has a priority of 20, that's more informational. So that allows you to sort of pick out the most important messages in the log. And then after that, we have the message text. So I mentioned using the thread ID from the point of failure to go back in the log. So I've taken one of my OSD logs where I've had an OSD that's crashed here. It's quite small, but I think at the bottom you can see where the abort signal's been caught. So that's the point where the OSD process was terminated. And in my text editor, I've sort of highlighted the thread ID and done a search on it in the text editor to pick out all of the lines in the log that are on the same thread. And so above those bottom lines, where there's a black space, there were loads and loads and loads of other lines there. And so I just want to completely ignore anything that doesn't look immediately relevant. So then I'm going back there. I can see, if I look up on that thread, BlueStore is doing something. I can see near the top, BlueStore is trying to do some sort of read, and it's trying to verify a checksum, and something is going wrong there. And I can look at the priority of each of those messages as well and see the negative ones where BlueStore is printing out errors. And so this gives me clues about why the OSD has crashed and some context. So something's going wrong with BlueStore. It's trying to look at a blob of data, and the checksum is wrong. So I'm thinking, no, okay, maybe this blob of data has become corrupted. Now, depending on your log level you have set for the OSD process, you may or may not see various messages. So any line in the code that prints out to the log will have a log level value. And so if I have my OSD logging set to level 20, then anything with 20 will be printed out, for example. But if my log level is set to 5, these messages won't be printed out in my log. And so if I don't have enough information in my log, I might want to go back. I might want to run a command to increase the log level and then recreate the issue. The thing about increasing the log level is it causes a lot of additional impact on the cluster. So that's going to use a lot of CPU and memory, and we're going to be generating gigabytes and gigabytes of logs very quickly. So increase the log level, get what I need, and then decrease the log level again. So you can use a command to increase the log level on a running cluster, or if you're having, say, issues during startup, you might want to change the log level in the config file so you can actually capture the logs when the cluster starts up and the OSD crashes, and then again change it back after. So in my log, I saw that BlueStore had hit an assert. So assertions are tests that developers add to the code to test that something is true at a certain point in the program. So, for example, that a value is within the expected range. We don't want the OSD to keep running if, for example, a value is unexpected and it's going to cause some sort of data corruption. We don't want the OSD to go and corrupt data. We want it to fail instead and terminate. And so when the OSD asserts, I get a stack trace, and this is printed in the log as well. And so the stack trace, I've only copied a bit of it into this slide because it goes on quite a bit, but we basically read that from the bottom up to the top, and that shows the function calls that were being run before the OSD crashed. And so looking at this, I can see we're in BlueStore. We're trying to do a write, trying to do a small write, and then we hit the assert line. And so when we hit the assert, we print out the file that we were that the function was in and the line number. And so that's useful because I can go and look in the source code and try and gather more context about what was happening. So looking here, that line doesn't really mean too much to me, but I can go and look at the code and try and gather some more context. So I've looked at my logs. I've seen that the OSD has crashed. I've got a stack trace. I see the assert in the file that we were in. What do I do next? So I would go to tracker.ceph.com and start searching for some of these things. So for example, that file name, bluestore.cc, and the line number, put those into tracker.ceph.com and see if anyone else has hit the same issue. If there were any error messages in the log, so here we had some verify, checksum bad messages. Those might be useful to try and search for on Tracker as well to bring up any issues that other people have hit. If you do find an issue, take a look at any stack traces that have been copied into that issue and compare them to your own stack trace. How similar are they? If they're very similar, then you may have hit the same issue. Even if there's some differences, it might be a similar problem. And that Tracker issue may have some workarounds in it to help you bring your OSD back, or it may point to a version of Ceph that contains a fix that you might want to upgrade to. There's also Slack that you can search for these types of things, and the mailing list as well, for, again, searching for error messages in the search strings, etc. So you've searched to see if anyone else has hit the same issue. They may have, they might not have. What's next? Well, let's go and actually look at the source code and see if we can find more information there and gather more context and more clues about what's happened. So download the Ceph repo. It's quite important to match the version of the source code that you're looking at to the version of the binary that was running. So actually check which version of Ceph the OSD is, because we hit that bluestore.cc line number assert, but those files are changed quite frequently, and the line numbers might be quite different in different versions of Ceph. So you can check out the version that you're using. And then doing a get grep can be quite useful. So for some of those error messages that I saw in my log, and that will point me to other points of bluestore that the code was running through at the time. And so, for example, here I've done a search for the checksum error, and it's pointed me to the bit of bluestore that's actually doing that checksumming. And so, again, this is all useful, giving me more sort of ideas about what's happened. And in this case, I sort of realized that I'd caused some sort of buffer corruption, and I didn't add a slide for this, but the next step was go and speak to the bluestore tech lead and get some help understanding exactly what bluestore is doing. And we eventually worked out why a buffer was being corrupted, and Alex helped fix that. And we moved on. So I just wanted to very briefly also talk about a couple of things you might see in the OSD log that's quite useful to understand. So if you have an issue and placement groups are involved, you'll see a placement group ID. So for example, 4.1 DS0, broken up. 4 is the pool number that this placement group's in. 1D is a hex value. That's the actual PG ID. And if you're using an erasure-coded pool, the number after the S is the shard, so you won't see that in replicated pools. And so as it was useful to search for the thread ID in the log and work backwards using the thread ID, it can also be useful if you're looking at issues with specific placement groups to search for those placement group IDs as well, and then sort of be able to focus in on the messages in the log that are useful. You might also see range values, which are used for reads and writes in the log. So for example, with erasure coding, we have a lot of messages printed out like this. And so this is basically a number with a tilde and then another number. The first number is the byte offset of the buffer that we're looking at, and then the second number is the length in bytes of that buffer. So these are useful when looking at specific issues in the OSD log as well. And that is everything I had. So thank you. I think I'm pretty much out of time, but okay. So if anyone wants to come and speak afterwards about any issues or anything, I'm happy to talk. But yeah, thank you.